How does specific heat capacity affect water temperature changes? Imagine holding a cup of hot coffee and a glass of ice water. The coffee cools down quickly, but the ice water stays cold longer. Why does that happen? It all comes down to how much heat water needs to change its temperature. Specific heat capacity is the amount of heat energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Water has a high specific heat capacity, about 4.18 joules per gram per degree Celsius. That means it takes a lot of energy to make water warmer or cooler. Compared to many other materials, water is slow to heat up and slow to cool down. When water absorbs heat, most of that energy goes into breaking the hydrogen bonds between water molecules. These bonds hold water molecules together, and it takes energy to loosen them. So, instead of immediately increasing the water's temperature, the energy first works on these bonds. When water cools, hydrogen bonds form again, releasing energy and slowing down the temperature drop. This high specific heat capacity helps water resist rapid temperature changes. Think about oceans and lakes. They stay relatively stable in temperature, even when the weather shifts quickly. This stability is important for aquatic life, which depends on consistent conditions to survive. Large bodies of water soak up heat during the day and releases it slowly at night, helping to keep coastal climates mild. Since most living things are made mostly of water, this property also helps keep our bodies at a steady temperature. When we exercise or get hot, water in our bodies absorbs heat, preventing us from overheating too fast. Conversely, when we are cold, water releases heat slowly, helping us stay warm. In practical terms, water's ability to absorb and store heat makes it useful in heating and cooling systems. Car radiators, for example, use water to transfer heat away from the engine efficiently. Climate control systems also relying on water's high specific heat capacity to regulate indoor temperatures. In summary, because water needs a lot of energy to change its temperature, it warms up and cools down slowly. This slow change helps maintain stable environments in nature and supports biological processes. Water's high specific heat capacity is a key reason why our planet's climate remains balanced and why living organisms can stay comfortable even when outside temperatures fluctuate.